All right, guys, here is the review for the logarithmic function unit, test number 12. I'm going to run through this. I won't go very slow because you can always pause it, rewind it. Okay, we're going to start with some graphing attributes of these log functions. So first we want to look at the domain of this function right here and the range. Okay, so the range, remember, is all negative infinity to positive infinity, all of these log functions. Now the domain is always going to go to positive infinity. We just have to figure out the starting point, which is also the asymptote here. So remember, domain is x values, range is y values. So we're looking at the x. That tells me right here, x equals, and right here, the helpful hint is x is in with the x. Sign change on that h value. So we put a positive 3. And we also put that right here in the domain. So that kind of takes care of 3 of those things. Transformations then, that is our AH and K. So there is no A. It's not negative. That would have been a reflection. You can kind of list it like that. You can go A, H, K. So there is no A value. There's no negative. There's no stretch. There's no compression. So we'll just say no change. The H is always the thing in the parentheses. Sign change. So instead of left 3, it's actually right. So we shift right 3. Units, and the last piece is the K value, which is out back or at the very end, out of parentheses. So a -4 will be shift down 4. Okay, so those are the transformations, and we're going to step right into some transformations again. So here's our parent function, f of x equals log base 3 of x. And we want to write an equation. So again, that's key for the test. They'll ask you for an equation. Make sure you write something equals. And in this case, g of x. So we have g of x equals, because they want an equation, reflection. That tells me there is a negative out in front of the log. Let's see if there's a stretch or a compression. There is not. So we took care of the reflection. Now we'll go ahead and put that log base 3, the x is in parentheses, 6 units to the left. So we're going to switch that sign. Left is normally negative. We're going to switch it +6, and it's in parentheses. Make sure you put it in parentheses, because if you just have negative log base 3 x -6 with, or +6 with no parentheses, then that's the k value. So there's the equation with the transformations. And what would the asymptote be? Well, we already know it's x equals, and you flip the sign. Okay, so make sure you flip the sign. X equals -6. Okay, now we're going to move on to expanding and condensing. With expansion, I like to count the number of bases. So I have a 7, an x, and a y. That means I'm going to need 3 logs. I'm going to have log base 2, log base 2, log base 2. Just give myself some room. Okay, on the top, I have a 7, and it's multiplication, a product. So we're going to split them up with the plus sign, and this would be our x. That's our other base. There is an exponent of 3. Remember, it comes to the front of that particular log, so that 3 right here is going to come down and go to the front. And then below that product, this is a quotient, so we're dividing, therefore we use subtraction. And there's no exponent on the y, so there's no number. We would just have the y right there. So there's my 7, my x, and my y, the 3 bases I need to expand. Okay, and you can put parentheses here if you want. You don't have to, since that is a separate product. All right, one more expansion. we have log 4x to the 5th. So again, here we just have two bases. So I need two logs. And it's multiplication. So I'm going to have a plus in between them. One base is 4, one base is x, and I'm looking at exponents. The 4 does not have an exponent, so there'll be nothing here. The 5 is an exponent on the x, so that 5 would move to the front, and that's it on that one. Nothing else to do. We expanded that log into its two logs. All right, now going the other way, condensing. We have 1, 2, 3 bases that are all going to kind of get put together. Up here we ended up with 3. We do have a subtraction, so we're going to end up with a fraction. So I'm going to start with any exponents. I don't have a number in front. I do have a number in front. So that 2 is going to go here. Remember, we're going backwards and no number in front. So I'm going to move that one first. Log base 7, 6 plus log base 7, 2 squared minus log base 7, 3. All right, I'm going to go left to right, order of operations here. So I want to do these two first, the plus. Remember, adding is multiplying. So I'm going to multiply these two together. Log base 7. And if I do 6 times 2 squared in Desmos or a calculator, so 2 squared is 4. 6 times 4 is 24. Then we have this minus log base 7, 3. Okay, now I have two logs I need to condense down to 1. I have subtraction, so just like up here, subtraction is a fraction, subtracting is dividing. So I'm going to condense down to 1 log, and I'm going to take that base and divide that base. 24 divided by 3. So that technically is now condensed down to 1, but since these are two numbers, I can go ahead and simplify it. 24 divided by 3, of course, is 8, and that would be my final condensed answer. Okay, this one's a little quicker over here. I just have 2 natural logs because of the ln. So I'm going to first move those exponents. ln x3 minus ln y4. All right, so now I just need to remember subtraction is a fraction. Go down to 1 ln. I'm going to have that over that. So x to the 3rd over y to the 4th, and that is my final answer there because I can't obviously simplify x's and y's. Okay, so now we're going to just do some converting. Okay, so we're just converting to exponential. And on the test, I recommended, if you do it this way, then on the other question, you can use it to kind of go backwards. So this is the easier one to do because there's 1 log. We always do that circle trick, as we call it. So I'm going to take the little base and raise it to that exponent. So we have 7x, and I'll just put it in parentheses since it's a product. Raise it to the 4th power, and then it is equal to the other leftover number there, in this case 2,401, and that's it. We're not solving it, it just said convert, so we are done there. So now I'm going to use this information to help me answer this, because I think this is more difficult to go to log form. Well, convert to log, I know I need a log in my answer. So let's look back at this one. The little number I need right down here came from the big number on the left. So the 5 is the big number on the left. So I'm going to put that little number there. Then the exponent is the number on the right. So 625 is the big number here. That'd be 625. And then equals 4. So right there. I don't know if you can see that. So you can always check it with the circle trick to get back to the original. 5 to the 4th power equals 625. So yes, we did that. Okay, so that's just converting. We're not solving. There are a couple questions like that on the test. Okay, so now this is going to fall in line with essentially this up here. Okay, we need to condense. Ignore the right side for now. Just focus on the left side. We're going to solve for x, but by condensing this, we'll get there. So again, start with those exponents. We have log 16 raised up to the 1/2 plus log 2 raised to the 3rd power. And that, of course, is equal to log x. So again, just focusing on the left side, we're in the same spot we were right here. When we add, we multiply. Remember, this number times that number was our 24. So 16 to the 1/2 power times 2 to the 3rd power. So 16 to the 1/2, you could just plug this and multiply it times that all in Desmos or your calculator. But 16 to the 1/2 is the same thing as the square root of 16, which is 4. And 2 to the 3rd power is 8. So I'm going to go ahead and do that extra step. But like I said, you can just multiply those two numbers in Desmos and you'll get what we're about to get. Okay, so 4 times 8 is 32. Okay, now this is just kind of a truth statement here. We have log number equals log x. So of course 32 has to be equal to x. X is equal to 32.